Lecture 3. It's a snow day again today. This is what we would have done in class. And again, there are no questions online, review questions on Moodle or anything like that. We're just going to go through the material that we would have covered in class today. So what does this print? We've got a for loop. Sum is 0. We're adding I each time. What are we going to get? So did you come up with 12? If so, you're correct. This is a disadvantage of having to do this over video. If I were doing this in class, we could kind of write this up on the board. But basically, I starts out at 0. That's the initializer of the for loop. We're going to continue so long as I is less than 10. That's the condition. The update statement is I plus equal 4, so we're adding 4 to I each time. And then each time in here, we're taking sum, which is initially 0, and we're adding I to that. So initially we add 0, so sum is still 0. We add 4 to I is now 4. 4 is still less than 10, so we do the body of the loop. Sum plus equals I. Well, sum is 0, I is 4, so now sum is 4. We get up here, we add 4 again to I is now 8. 8 is less than 10, so we do the body. Sum is now 4. 4, the sum of, we're going to add 8 to that. Sum is now going to be 12. We add 4 to I up here. I is 8. That's now 12. 12 is not less than 10, so the loop ends or kicks out. And then we get down here to all the stuff after the loop, which is going to print out sum, which is currently 12. So that's what's happening there. And then here is a chart sort of tracking the values sort of as I changes and as sum changes, and once I gets to 12, the loop stops. We check the condition, it's no longer true, and we exit the loop. So what does this print? And this isn't literally asking what it prints. It's saying, well, is it going to compute whatever these sums are and then print those? So it turns out this will actually print 0. The reason being, we initialize I to 0, and if we check the condition, well, it's I greater than 100. Well, 0 is not greater than 100, so the loop body never executes at all. We just immediately go down here and print out sum. Well, sum is 0. So this is something to keep in mind. If you write code and nothing happens and you keep getting 0 or you don't get any print statements or something like that, it could be something wrong with your loop. You could have a situation where you've got I greater than 100 instead of less than 100, or possibly less than instead of greater than if you're counting backwards or something like that. And that's just something to keep in mind. You want to make sure you're able to catch those things and fix them. A good way to check on this, so if you had code like this and it kept printing 0 and you didn't know why, you could stick a print statement inside the loop, and then when you run it, you should just get a whole bunch of print statements getting spit out. If you're not, that means probably something's wrong. The loop's not happening. The loop body never executes. So what does this print? And so note that this print statement is printing I, and then it's concatenating a space. So we're going to get the value of I with a space after it. What is this going to print? Hopefully you came up with C. I've got a demo of why this is happening on the next slide, but just kind of intuitively, we're starting I out at 6. We're looping while I is greater than or equal to 2, and we're doing I minus minus. So this is kind of an example of a loop that's counting backwards, and it's going to execute when I is 2, because 2 is greater than or equal to 2, but once I gets to 1, the loop should kick out. And so here's kind of what's happening. As the value of I changes, this is sort of what the output looks like. And if you notice, this is a print statement, not a print line, so it's all going to print on the same line. We're not actually going to get any enter keys or new lines because we're not doing any print lines in there. How many times does this execute the print statement? So it's going to print all the values of I, but how many times is that going to happen? Can you kind of just look at the loop header and figure out how many times this print statement executes? So if you came up with infinite, you're correct. this is another common problem with loops if you're not careful. This loop is clearly set up to count down, right? We're starting I out at 10, we're going while I is greater than or equal to 4, but we're doing I plus plus instead of I minus minus, right? So I starts out at 10, 10 is greater than or equal to 4, we print 10. We add 1 to I is now 11, 11 is greater than or equal to 4, we print 11. I is now 12, 12 is greater than or equal to 4. This is going to go on forever. So this is an infinite loop. It's technically not infinite. Once we get up to about the maximum possible value of an integer, it'll roll over to the minimum possible value of an integer. But that's going to take like 2 billion repetitions, and so for all intents and purposes, this loop is infinite. It's certainly wrong, and that's because this probably should be I minus minus, because it looks like we want to have the loop count downwards. That's another thing to keep track of. If your loop's running forever, seems to be running forever, and you're trying to count down, make sure you're doing minus minus or minus equals something. So what does this print? Not the exact, so we don't know what n is, but let's assume that n is a positive value. And we want to know what this is going to print as a function of n. So these are our possibilities. So did you come up with 2 to the n? If so, you're correct. We've got this result. We're starting out at 1. Here, instead of doing plus equals, we're doing times equals. So we're multiplying result by 2 each time and then reassigning that to result. And then I is going from 1 less than or equal to n. So suppose n is like 3, right? So I starts out at 1. 1's less than or equal to 3. So result times equals 2. Okay, so result is now 2. We add 1 to I is now 2. 2 is less than or equal to 3. So result times equals 2. Result's now 4, because previously it was 2. 2 times 2 is 4. Add 1 to I is now 3. 3 is less than or equal to 3. So result times equals 2. So result was 4. 4 times 2 is 8. Result is now 8. Add 1 to I is now 4. 4 is not less than or equal to 3. And so the loop's going to kick out. Result will be 3. We can very clearly see that this is going to compute 2 to the power of n. So a good question, what happens if we put a for loop inside another for loop? So I've got some slides to kind of motivate this. So suppose we assign sum to 0 and we keep doing sum plus equals 1. Maybe we do that 4 times. And we want to turn this into a loop. We could do that, right? We could write a for loop. We could start I out at 0. We could do I less than 4, I plus plus, and do sum plus equals 1. This for loop, starting out at 0 and going strictly less than 4, that's going to go 0, 1, 2, 3, which is obviously 4 numbers. So that's going to execute this statement 4 different times. So this for loop has the effect of doing this 4 times. And if we change this value here, if we make this 10 or 100 or something like that, it changes how many times this body of the loop gets executed. So that's pretty cool. Going back one slide, we want to take this code, turn it into a for loop. Bam! We can go ahead and do that. But now, okay, we initialize sum to 0. Now what if we have 3 different for loops and we want to turn that itself into a loop? So we want to have a loop that runs this for loop 3 times. So if we look at this before doing that, sum starts out at 0. Well, this does sum plus equals 1 4 times. We know this does sum plus equals 1 4 times. And this does sum plus equals 1 4 times. And they all happen one right after another. So at the end of this, what should sum be? Right, it should be 12. But a for loop can repeat any body of statements, any block of statements, including other for loops. I know it's totally meta, but we can do that. So we want to run this for loop 3 different times. It's exactly the same for loop. Bam! This is the for loop from the previous slide. We're actually wrapping around it another for loop to execute 3 times. Now, we can't have this for loop be I and this one be I for the same reason that we can't create some integer variable x twice. We saw that in a previous set of clicker questions. So what we need to do is come up with a different loop counter. We'll go ahead and call it j, right? So now this outer for loop executes 3 times, and what it executes 3 times is the entire inner for loop. So when j has the value 0, I is going to cycle to 0, 1, 2, 3. Now when j becomes 1, I is going to cycle through 0, 1, 2, 3 again, right? Because each time the body of this outer loop executes, the inner loop, it has to run to completion. So the net result of this is we still do sum plus equals 1 12 different times. 4 times in the inner loop, and for each inner loop, there's an outer loop. There's 3 outer loops. So for each outer loop, we do 4 executions of the inner loop. So this ends up doing sum plus equals 1 12 different times. This is called nesting. So here's a nested loop example. I actually gave the answer to this away. That's kind of disappointing. So what does this print? Right. It prints 12. And I would draw this on the board if I had a board to draw things on. If you sort of go back through the slides, you can kind of maybe see more clearly exactly what's happening. Let's try another example. So here we've got both outer and inner, right? And then we're incrementing the outer counter inside the outer loop. We're incrementing the inner inside the inner loop. We're printing out both of them. So which of these is going to get printed if we run this? I realize I stuck a comma in there. Pretend that that's just a space and there's no comma, because we don't want it to be none of the above because of that. So this one's actually going to be 100 and 7500. The reason being, outer is going to execute 100 times, right? This J loop, we're going to get 100 iterations of that. But for each one of those iterations, we're going to get 75 iterations of the inner loop. So if 100 times you do something 75 times, that's going to be 7500. So inner is going to be 7500. Outer, on the other hand, is just going to be 100. So that's what we're going to end up with. Let's try one more example. Now we're going to add a third loop. So we have a J, I, and a K loop. So what's the value of sum going to be for this example? Give you a chance to think about that. So this is going to be 15,000. The reason being, this is it 15,000 or 1,500? Well, let's see. This is 10. Oh, crap. I think it's 1,500. This is 10, and if 10 times you do something 75 times, that's 750. And if you take something 750 times and do it 20 times, that's right. 750 times 10 would be 7,500 times 2 would be, 15,000. No, this is totally 15,000, right? Because it's 10 times 75 times 20. God, I hope that's fit. Let's test that, just make sure that my math is correct here. 10 times 75 times 20. Yep, 15,000. It's totally 15,000. And the reason I'm picking large numbers so you can't just kind of count these out rather than like 2 and 3 is because you got to be able to look at these loops. And if it's a pretty basic loop where you're starting out at 0 and you're going strictly less than some limit and you're incrementing by 1, you should be able to look at that loop and realize exactly how many times the body of that loop is going to execute without having to calculate it out. And that's all we've got on that. Awesome. Thank you very much.